Hi, George Durkee, Columbia College GIS, and in this video we are going to look at obtaining and downloading your own geospatial data to use as base maps. And this video is meant to replace the assignment for week 2 or 3, which is pre-planning, finding, and obtaining geospatial data. That video covered going to the California Geospatial Clearinghouse and downloading USGS digital quads, which you could pull directly into ArcGIS and use them as your base map. And that's unfortunately no longer possible. That site disappeared, and you now have to go through. The best bet is what's called the USGS National Map, and there we'll be able to get what's called a GeoPDF, which unfortunately we have to convert to a GeoTif before Arc can actually use it. Now, the advantage of having your own maps on your hard drive is that they're there pretty instantly. And if you have a slow internet connection, which many of us in Tuolumne County do, or you don't have any internet connection, and I often work in the field, and I carry a full map set of most of central and southern Sierra with me. So when I'm working on a search and rescue or even a fire, I'll have a map set with me that I can use totally disconnected from the internet. So a GeoPDF has the spatial information with it, but it's it's got some disadvantages. It's a PDF and it's an exact copy of a USGS paper quad. So in addition to having the map in the central part of the map, it's also got what's called the collar, which is tick marks for latitude, longitude in decimal degrees or UTM. And then at the bottom here, you've got specific information on the map and the symbol types. And at the top, obviously, you've got USGS map and all that sort of thing. But if you're using that within ARC, you don't want this collar, because if you have adjoining maps, the collar will cover each other, and you'll lose a lot of terrain information. So the workflow I'm going to go over here will show you how to download a GeoPDF, convert it to a GeoTif to use as a base map, then remove the collar. And we'll also take a close look at a couple of different types of maps and show you a couple of cartography choices in labels and colors and so on that cartographers use, which you always want to be conscious of when you're making a map. And on the assignments, I'll also send out direct links to other sources for online maps. So you've got the Add Data tab on ArcTen itself, and that gives you a choice of either base maps, or you can search for various other specific types of maps. And then ArcGIS also has the Living Atlas of the World, which is searchable, and you can search for a huge amount of information. Here I've got it searching for USGS topos, and you can find historical topographic maps. So you can find a map of Yosemite in the late 1800s and the survey work that had been done by then, and all sorts of other pretty cool maps if you're into maps. But it's got other information in addition to maps. And I won't cover it here, but when you click and go to the map itself, it'll give you a link that you can pull directly into Arc, and it'll connect you to the server, and then the map will just be part of your project. In addition, there's local sources. So the college has a pretty good data set for the county. It's got roads, trails, structures of the county, which you might find useful, and other unassorted data. And Jeff Tolhurst will be able to tell you where on the network you can find it. You can also check with the county GIS office. A lot of their geospatial data is posted online. They also have structures, parcels, though that may not be publicly available, but all sorts of data there you can use. And the Forest Service has a huge data set, the Stanislaus National Forest. So if you work for them or BLM, or if you need a specific file, you can actually write them and ask if they'll provide it. And most places nowadays are pretty good about providing data. And they actually also have, for the Forest Service areas only, they also have USGS quads, which you can download. But for what we're doing today, we're going to go to the USGS, the National Map, and there they've got a lot of resources for maps and data, and a good training course on how to use all their resources. And from there you go to the map viewer, and this is exactly what it says it is. It's a viewer, and so you can zoom in on a particular area and see more detail represented in one of several maps you can use as base layers. But what we specifically want to do is get data, and so you go to data download, and you can use the search box here. So we'll type in Columbia, California, and two choices come up, and from experience I know that one takes us to around the Mount Shasta area where there must be a Columbia, but we want the top one here, and you'd quickly figure out that you don't want the other one. So here we are with Columbia, and let's just zoom in. There's the airport, and so the way to do this is, you'll notice on the left here you have a lot of choices of types of data you can search for. So at the top here is US Topo, which is what we want. You can go back and you can find historic topographic maps, but you've also got boundaries, elevation layers, elevation source data such as LiDAR, which is pretty fun to work with, but kind of advanced. Hydrography, which is streams, imagery, where you can get satellite imagery, and so on and so forth. And transportation, roads, structures, you actually have a national structure database, although I'll add that the one for Tuolumne County that the college has, and now the Forest Service is more up to date and accurate. So what we'll do here is we'll just check US Topo, and it shows us US Topo current. And if we do non-current, it'll give us the historical ones, but we'll get the most current one. And then we just go to find product, and we go to, there it is there. We can see a image of it, but let's not take up the time for that. We'll just download it. And because you guys have all downloaded the GIS data, which means I have to find my C drive. There we go. The GIS data template that I sent out. There we go. That allows you to put everything in an organized file structure. So you'd go to base data and topo maps, and I've already downloaded it, so I'm not going to do it again. It takes, I don't know, 20 seconds depending on your bandwidth. And then you save and use the file name they've got, which is pretty good, California, Columbia, and download it. And again, what you get is this USGS quad, And let's magnify it a little bit. So you can see here, close up, you've got roads and contour lines, elevation lines at a specific distance. And on the edges here, you have tick marks for latitude, longitude in decimal degrees and in UTM. And if you've looked at the uh, at the assignments on coordinate systems, you'll know what those are and when you use them. But as I said, this is not directly usable by ARC10, and you also have the problem of the collar here, which you don't want. You just want the terrain map here. So let's go through the workflow to convert this to a usable form so you can use it right in ARC and get rid of the collar. So ARC10 has a tool, PDF to TIFF, and that's what you want to use. So you go to the search window, which I have set up to catalog here, but if it's not immediately on your screen, go to Windows and go to Search, and that'll bring up your search window. And then type in to the search box PDF to TIFF. That's two F's. If you use one F, it won't find it. And then you click to link to the tool, and it should bring it up. For some unknown reason, it doesn't bring it up in my computer, so I've actually got to use the file path to where the tool is, and that brings up the list of tools you have, system toolboxes, and PDF to TIFF. And then I just double click that and bring it up. So here are your file inputs, input PDF file. So for that, we navigate to your C drive, if I can find it. There we go. And the GIS data folder, and work your way down to topo maps. And there is the file you want to convert, the PDF, and it says GeoPDF to tell you that it has geospatial information with it. And just click Open. And it'll automatically put in an output name. It'll keep the same name, and it'll put it in your documents ArcGIS. But in fact, it's better if we have that in our topo folder. So let's just copy that and then replace the ArcGIS with that. Make sure you didn't somehow get in two forward slashes to confuse things. Keep everything else the same, but under color mode, you want to use the RGB palette, and that'll give you the full palette of colors that the map will create. And I'll show you why that's important later. And then just click OK to run the tool. And you notice down in the lower right here, it's telling you it's running. So I put the recording on pause, but it takes about a minute, 45 seconds, a minute or so to convert, and then you get the map. And so let's zoom out a little bit here. And so there's the problem I talked about earlier, is that you have a map, but it's still got the collar information. So if you're working with just one map, that's not hugely critical. But if you want a map set of the adjoining maps, you don't want that collar because it's going to overlap and cover the terrain information of your other maps. So our next step is to remove the collar, and it is a little bit of a clunky process, and certainly things were better in the olden days when you could just get a map without the collar, a GeoTif without the collar. But here we are, and I'll show you the easiest way I've found to do it, and there may be other methods, and usually you'll find with ArcGIS there's usually 3 or 4 or 5 different ways to do anything. But here's one method that's pretty easy. So one of the files I've put in the files, and I'll link to it on our Canvas site, is the map index to all quads in California. So let's zoom out here to show you what we have. Zoom to layer, and there are all the quads in California. And then we'll just go back to where we were. So you'll notice that the quad rectangle fits exactly over the quad, which is what you expect, and leaves out the collar information there. So now we want to click inside the quad rectangle to select it, and notice how it's now outlined in blue. So what we're going to do, and there are a couple of ways to do this, is clip the raster file, the quad, and there's also a clip to raster tool, but we're going to use what's called the image editor, and that's under Windows, and go to Image Analysis, and with your quadrangle highlighted here, make sure you highlight the file that you want to clip. That shows everything in my catalog over here, our table of contents, and so that includes the scratch data in there. But so have your the file you want to clip there, and then just go down and clip. And that shows up with clip on the file name. And notice how the collar has disappeared. Let's unselect the other map, which had the collar. And so we now have the clipped raster without the collar. Now, this is only a temporary file. The image analysis works pretty quickly, and it allows you to adjust other things such as color and so on and so forth in your raster file. But I also found it to be the fastest way to convert. So now we're going to go up here. We're going to save the name and just save from California, Columbia, and to there. Copy that, and you'll see why we're doing this. So now go to save. Oops, make sure you've highlighted that you're going to save the clip, and go to save. And then you get a dialog box, and fill in here the name you just copied, and make sure it's going to Topo Maps, and go ahead and save. And yeah, you can just go ahead and yes on that, and add it to the map. So now we've just created a, we can get rid of all this now, get rid of the clip, and so we've created a raster without the collar. Okay, that's a little clunky, I cheerfully admit that, but unfortunately when only GeoTifs are available and you want a faster loading map, or you want to keep your own map set, that's the way you have to do it. I keep searching for different methods, and if I find something, I will post it and send it out to everybody. And one thing I do here is I keep a scratch data layer in here. So I get rid of everything that I'm not using. So I get rid of the clip there. And we're not using, well, actually, I'll say one thing about the index. When you get the index and you load it for the first time, it's going to be filled like that. Let's also uncheck there we go. So it'll be filled, and so you just want to make sure you just do the outline. So go ahead and click on the symbol, and for the fill color, choose no color, and increase the outline width a little bit just so you can see it clearly, and click OK. And there you go. I made it blue on this round, but black or whatever. And then, of course, you're always saving within ARC10, just in case things go kablooey, and you can get back to that. So we don't need image analysis anymore. So you can do that for contiguous map quads. You get them off the USGS site. You can download a whole bunch at once, and then one by one go through and convert and get rid of the collar. As I said, kind of clunky, but there we are. Now one more thing I'm going to show here. You may have occasion to change the colors, and you can do that, and that's why we created the RGB with a full color palette. Let's get rid of the index here. And so here, just as an example to compare, let's bring in the original TIF for this quad that we got when the site was still active, and we'll put that on top here. And notice the color difference there, very bright green versus a more subdued darker green here. So you may have occasion to want to get rid of a bright green, or in the case of the Forest Service for fire, they actually get rid of all color on the map, and so you just see the browns of the contour intervals and the white space, and the place names and roads are all there, of course, but they just want a basic map for fire. That was done mainly, I think, so that they could photocopy them, although now with modern printers you can churn out a zillion copies without much trouble. Let's zoom in a little bit here. And there we are in Columbia. So then we switch over and notice all of the color indexes right there, and each corresponds to a layer of pixels on the map. So what we'll do here is get rid of the top layer. We just want to look at this layer here. So click on that color, and you'll notice it's going to be, the value is going to be index color number 54 here, which is down here, and it gives you the RGB settings, and we're interested in the RGB, the second set of three numbers here, 235, 244, and 216. So you make note of that and go back to your original here, and the color index isn't always in the same place. So let's do the brighter green here, and notice that's color index number 6. And the settings there are 210, 255, 177. But just for argument here, let's say that's a little too garish for our purposes. And so you go ahead and you click on the color symbol, and then get yourself to the color itself, and then choose more colors. And so there's your current settings. And so we want to set it to the settings for the other one. So that was 235, 244, and 216. And let's click OK, and OK again, and OK a third time, and it changes it. So now you've changed all the colors to a more subdued green. And you can also get rid of it if we change that to no color. We'd get rid of it entirely. And so that's what a Forest Service fire map will look like. They just get rid of the colors. Okay, that's it for this session. In a future session, I will show you how to download an elevation model, and from that we will convert it to hillshade. And hillshade is something you can add to a map. So notice how you have the texture here giving a 3D-like effect and showing where ridges and drainages are. And So a lot of data sets have hillshade already done, but if you're in an area where you can't find a hillshade layer, we can create that within ARC10, and there is, of course, a tool for doing that. Okay, thanks a lot, and I'll post the link to that next video in in the assignments tab. Okay, thanks a lot.